In this video, we are going to continue to expand our knowledge on operations with polynomials. First, let's review some general information about the standard form of a polynomial. The standard form of a polynomial arranges the terms by degree in descending order, numerical order, meaning that they start with the highest degree exponent and end with the lowest degree exponent, as we can see in the example below. Now, the degree of the polynomial is the number of the highest exponent in the polynomial. Now, if we have a degree of 0, that means it's just a constant. Degree of 1 means the highest exponent is 1. 2 is x squared, so that's quadratic. 3 is cubic, which is x cubed. 4 is quartic, which is x to the fourth. And 5 is quintic, which is x to the fifth. You can also classify a polynomial by the number of terms. A monomial means it has one term. A binomial has two terms. And a trinomial has three terms. In order to add polynomials, you are going to combine like terms and rewrite with the exponents in descending order. The important thing about this is that you need to make sure you're always starting with the highest power exponent. So in this case, the highest power exponent is x cubed. So I have a 2x cubed and a 5x cubed. So I can combine the 2x cubed and 5x cubed become 7x cubed. Now the next highest power I have is x. So you have a 7x and a 2x. Now if I were to add 7x plus 2x together, it would give you 9x. Then the next highest power we have is the 2 and the 5. So if we were to combine the 2 and the 5, it would be 7. So your final answer is 7x to the third plus 9x plus 7. Now for our next example, we're again going to start with the highest power exponent. So the highest power exponent we have is x to the fourth. So if I were to add x to the fourth plus 7x to the fourth, that would give you 8x to the fourth. Now the next highest power exponent is only x to the third, which only appears in the second part of the equation. So that means that it will become minus 3x to the third. The next highest power exponent is x squared, so you have 4x squared and 3x squared, which combine to be plus 7x squared. And then the only remaining term that we have not used is the 2x, so our final component is plus 2x. And that would be your final answer. In order to complete subtraction of polynomials, we first have to distribute the negative. So if I think of this as being a negative 1 in front, you have to distribute the negative 1 to each of the terms and rewrite it. So you have 6k plus 5k to the fourth plus 3, and then negative times ak becomes minus ak. Negative times negative k to the fourth becomes plus k to the fourth, and negative times 5k times 5 becomes minus 5. Now we need to combine starting with the highest power. So the highest power exponent we have is k to the fourth. So we can combine the 5k to the fourth and the k to the fourth to become 6k to the fourth. Then we can combine the 6k and negative 8k to be minus 2k. And then lastly, we can combine the plus 3 and minus 5 to become minus 2 to give you your final answer. For the next example, we again have to start by multiplying the negative. So if I distribute the negative to all the terms, I start with 5m squared minus 3. Negative times 6m squared becomes minus 6m squared. Negative times negative 8 is plus 8, and negative times 8m to the fourth is minus 8m to the fourth. Now we have to combine like terms. So the highest power exponent in this case is the negative 8m to the fourth. And that's our only one, so it becomes negative 8m to the fourth. Then the next highest power exponent is m squared. So we have 5m squared and negative 6m squared. And 5 minus 6 will give us negative m squared. And then the next highest power is just a number. So we have minus 3 plus 8. And we combine those two, the negative 3 plus 8 will become plus 5. And that gives you your final answer. In our last example, we're multiplying polynomials of a higher degree. Now, in order to do this, we're still going to multiply every single term out, but we're just going to make sure that we have to distribute it one more time. So I'm first going to distribute the 2x to the 8x squared. So you'll have 2x times 8x squared. Then we're going to multiply the 2x to the 3x. So it's plus 2x times 3x. And then we're going to multiply the 2x to the last term of negative 5. So it's plus 2x times negative 5. Then I'm going to multiply the negative 8 to each term. So I'll have plus negative 8 times 8x squared plus negative 8 times 3x. So negative 8 times 3x. And then lastly, it's going to be plus, and you're multiplying the negative 8 over the negative 5. So it's negative 8 times negative 5. Now when you multiply each of these out, 2x times 8x squared becomes 16x to the third. 2x times 3x is 6x squared. 2x times negative 5 is minus 10x. Negative 8 times 8x squared is minus 64x squared. Negative 8 times 3x is minus 24x. And negative 8 times negative 5 is plus 40. Now the last step is to combine like terms. So we can combine the 6x squared and the negative 64x squared, as well as the negative 10x with the negative 24x. So my final answer will become 16x to the third, 6x squared minus 64x squared gives you minus 58x squared. Negative 10 minus 24 is minus 34x plus 40.